Tiana, I know she said she's a bit late. I'll call her anyways. So, I mean, and once you know that, where are we? Once you know that and you're able to apply that, really the equation is really easy. Because to find a vertex, you should know by now, it looks something like this. Right? So it's x squared. Now, if it's not at 0, and if it's at positive 2, you know, usually you make this bit equal to 0 to solve for your vertex, your x-intercept. Do you get that?
Yeah.
So what would this is shifted to, you're making this bit equal to 0. Yep.
Mm-hmm.
And then you would say, okay, if it's at plus 3, well, plus 3 is usually plus 3. You don't change that. You don't make that into a negative 2 like we did here. So that should become plus 3. But the problem is if I plus 3, it'll look like this. You want it the exact opposite way around. So what you're going to do first is make this into a sad face, which becomes negative x minus 2 squared. And then what do?
Shift up by 3.
Shift it up by 3, you're done. That's this equation. You want to double check it? You know, you could expand and simplify and then sub in your vertex and it'll work out. The only thing you have to double check, which in this case I obviously added as an extra step, is this negative 1 and 5. You've got to see if in this case 5 and negative 1 works, which it doesn't because I didn't make it work. Like I just chose this 3 randomly. I don't even know if it's going to fall into here. So what you would have to do is sub in 5. So it's not really going to be as hard as I've just made it, because I'm obviously making it up, but let's do it anyways. What do you know the x value here to be?
5.
And what do you know the y value to be?
0.
So that has to happen. If I sub it into this equation, and if it doesn't, then I'm going to adjust it somehow. And the adjustments are usually this number here. Right? Because you can't change this. Can you change x minus 2?
No.
No, because that's the vertex at positive 2. Can you change plus 3? Can you change a negative? So you really can't change anything except the number that it's multiplied here. Cool?
Yep.
That's it, really. You label that as, let's call it capital A. And that's the hardest step that a lot of students don't do. So you sub in x is 5, y is 0, and it looks like this. And this, you only need to ever do this for questions that are, I guess, that are nothing flowed. 0, take away 3. 5 take away 2 is 3. 3 squared is 9. You've got negative 9a equals negative 3. So therefore, divided by negative 9, a equals to 1 on 3. So therefore, y equals to negative 1 on 3, negative 1, negative 2 squared plus 3. Sorry, what the? Did I just write negative 1? Are you serious? What was that meant to write there?
X.
Yeah, obviously. X minus 2 squared plus 3. Do you want to double check it now? You ready?
Mm-hmm.
Sub in negative 1. What should happen?
Y should equal 0.
Let's hope so. Minus 1, minus 2 squared. What's negative 1, negative 2 squared? So negative 1 take away 2?
Negative 3.
Negative 3 all squared?
9.
9. 9 divided by negative 3?
Negative 3.
Negative 3. Negative 3 plus 3?
0. Oh.
It has to work. And that is the strategy for it. That's how you do it. It will work. You just pick one, pick at 1 point. So if you can, I mean, we'll be looking at exams today, but if you actually have questions, like you came up to me and said, hey Sam, let's do, finding graphs finding equations of graphs. But if you have specific questions, it's a lot better. Because then I'll know exactly what bit is confusing you. Cool. And obviously, if I didn't give you -1 and 5, I gave you a number here and I gave it to you as 2. You'll do the same thing here. You label this as A, and you're just going to sub in Y is 2 and X is 0. You good?
Yeah.
Done. Yeah. Anybody else have any questions? We're just doing revision. Anything that you want to talk about? Anything that you're learning at school that's still confusing you? I'm just waiting. If you guys have nothing, then I'll be doing. I'm just going to go through a whole lot of bunch of Year 11 papers. Don't forget the website's called THSC. Yeah, you got some from 2018, which we will do. Math yearly exams, Year 11. Why not? Let's open that up. Save it. It's time for you guys to do the same thing. And you know pretty much what we have studied and what we haven't studied. So you'll know if it's something that you can answer or something you should be able to answer compared to something that we haven't studied yet. So you don't need to worry about it too much. Just waiting for it. 3, 4. So I'm opening up more yearly papers just because I know exactly yearly assessments. I know pretty much what is obviously assessed and not. You guys might want to look at half-yearly exams. That most likely would cover most of trig and functions. Sites to load would be fantastic. Download. Let's try it again. Can we save this or what? Script.google.com. All right. Well, while it's waiting, we're going to start anyways, and then I'll try to put it onto my program. All right, here we go. So, what are the solutions of 2x squared? Take away 5x. Take away 1 equals 0. What do we do?
Complete the square.
You reckon? I don't think so. I think quadratic would have been great. Yep, quadratic formula. So let's go. Quickly get your piece of paper out. Write revision if you want to write the school, so that you know. I mean, if instead of paper, actually, if you have a book, it's called your exam book from now on, and we're going to be going through exams for the next 4 or 5 weeks. So all we're doing is just a whole bunch of revision until we are really good at all this. And then call it Borkham Hills 2017 and question 1. So yep, quadratic formula. Go and quickly do it. We're waiting for this. Tiana, I got your message. All good. Waiting for script. Okay, how am I going to fix? I'm going to fix it. Please let me know once you got an answer. Anyone confused? Okay. Might link this to you guys as well. Actually. We still not got an answer. Question 1.
I have one, but like, I don't know if anyone else.
Me too.
Which one? Yeah, what's the answer? A, B, C, D?
D.
I got D, yeah.
Okay. Anyone not able to get D, or is anyone actually seriously confused? I don't know. You guys took a bit of time there. D? Anyone? All good? I got D too. Perfect. Dinesh is in. Perfect. All right. I'm guessing everything else fine. So geometry, out of the syllabus. So if you see any geometry questions, you don't need to worry about them. Gone. Cool. Okay.
How do we know if it's geometry though?
Look, it's a shape. It's got angles and bisecting, let's say. So that's definitely geometry. You haven't done anything like that anymore in year 11 and 12. You don't do any more like that. They're gone.
Oh, I'm back, Sam.
Cool, cool. All right. You'll tell it. Look, again, what do you think I would say other than that? The more you expose yourself to all of these papers, you'll realize which one's geometry and which one isn't. Yeah?
Okay.
All right, here we go. Which graph best represents this function? 3 to the negative x. Be careful. I think we just did this last week, didn't we? Exponential.
D?
Just wait. Keep it to yourself for a second. Just let them. I'll ask. 1 sec. Have to think about it. Marks count. Don't take it easy. Don't just go, oh, is it A or is it B or whatever. Assume it's your actual exam. What would you do in your exam? Would you just look at it? I personally wouldn't. I would, substitute some numbers, make sure it works, and really think about it. All right. I can see. Just stop this now. What's the answer? So what did you say? Eden, I think that was you, wasn't it?
Yeah.
What did you say?
I said C, but that was just like first inspection. So,
Yeah. Upon second inspection?
mm,
No? Still C?
I think B.
Okay.
Yeah.
Anybody else?
I think B as well.
Yeah, I got B as well.
I think this one here is what? 3 to the power of?
X.
Perfect. When they flip down, they've got to be negative 3 to the x. This one here is 3 to the negative x. Good job. It is B, not C. You can't do that, Eden. You just lost yourself a mark. Not allowed. Right? Don't do that. Try to hold off. It's very tempting, especially with multiple choice. All right. What you guys probably saw, I'm using Chrome. It didn't allow me to download for some weird reason. It wasn't working. Now, usually Firefox doesn't have that problem, so I downloaded Firefox and it worked. Well, it had a problem with pop-ups. I allowed it, and then I downloaded it straight away. So just so you know, if you're having issues with this, especially on Mac, I know that it will not open at all because Safari won't allow it. Just be aware of that. We've got this one. Bring it here. We're going to continue with the 2017 for now, and then I'll download this at the same time in Chrome. Okay. All right, number 5. What are the solutions of root 3? Okay, wait. Again, can you guys see it's the same questions we've been doing? Like, it's not any harder than you know, our standard questions we've done, and that's how your exams will be. Your year, Borkham Hills. This is second best school in the state, right? So their top school. If this is the question they're given, that means it's a question you'll be given as well. So what are the solutions of root 3 tan x equals -1? Can anyone tell me the only thing I want to hear when I see a question like this?
Don't inverse negative.
That's exactly what I like to hear. Because if you can teach it the way I teach it to you, then you know your stuff. So root 3 tan x equals -1. We've got root 3 solve. We've got root 3 tan x equals -1 for 0 to 360. So your first line is you divide by root 3. Your second line is you write x with inverted commas equals inverse tan, never a negative. You don't inverse a negative 1 on root 3. Then you get your answer for inverse tan 1 on root 3. Ringing a bell? 30?
Yeah.
And then what do we draw?
Orthostatic to central.
Bang. And then what do I say to myself here?
10 is negative in quadrant 2 and 4.
And then I write, therefore, x equals 180 minus 30, 150, 360 minus 30, 330. And you go back to the paper, you go look for 150 and 330. Right there, done. The answer is D. Anybody need more work on this? No? Happy days?
Yeah.
Cool. Happy days. Don't make it harder than I've made it. If it's that simple right now, then it should be that simple in your exams and when you're learning it at school and everything else. Cool. We keep moving. Okay. Focus, directrix. These words are out of the syllabus. So if you ever see this and it says, what is the equation of the parabola? Gone. No longer in your syllabus. So focus, directrix. We've never spoken about it, so not in your syllabus anymore. Cool. Keep moving. What is the gradient of the tangent? Is that in your syllabus?
Yeah.
What does it mean by gradient of tangent? What do we do? What topic?
The trigonometry.
No, wrong. Good try.
Not in the similar.
Function?
Say it again.
Was it a function?
It was not. It was one that we recently did.
Oh, calculus.
It was calculus. Right? Gradients of tangents. And so how do we find gradients of tangents? Come on. Come on, come on. Remember, this is your exam, and you're thinking about it, and you're gonna be like, oh, how do I find the gradient of the tangent? And you just worked out it's part of calculus. What's the whole point of calculus?
Oh, differentiate.
Differentiate, right? The whole point of calculus is to differentiate. There's no point of it ever even thinking of this word calculus if you don't know the word differentiate. So, how do you differentiate this? So the gradient of a tangent, so you guys remember, is just y dash, and then you got to sub in 0. How do we find the gradient of this tangent here? What do we use?
Is this the VU?
Yep, so what's it called? Product rule. Why is a product rule? Because you just said it, there's two x's that are multiplied, uv. So y dash equals u dash v plus v dash u. U dash is what? What's the derivative of the first bracket? Lisa,
Is it
do it with me. X becomes 1. True?
Yeah.
So you decrease. So the logic was like this. Let's just recap that. Bang. You bring the 1 down, which is 1. X. You take away 1 from that. So 1 minus 1, which is 0. X to the 0
it's just one?
is 1. So 4. If I had 5x, we said we understand that you got to keep decreasing it, so that becomes 5. But if we had 5, your y dash is 0 because there's no x's. Rings a bell?
Yeah.
Let's go. So u dash, what is u dash again?
1.
1 times v. Well, v is just v. Plus v dash. What don't I like about this?
The square root.
Yes, so what must this be written as? Power of?
Half and a half, yeah.
You said it, you said it. Okay, now bring it down. Say it.
And then it's half. Yeah, it's just half. Yeah. And then x plus 1.
And then to the power
Negative.
of
Negative half,
y.
because you take away 1.
Beautiful. Then you got to, technically, chain rule says you have to differentiate the inside as well. In this case, derivative of the inside is just 1. So you could have ignored it, right? But I just thought we'll talk about that. Times, so that's v dash. What do you have to also multiply by? U.
Okay.
Right? So you finish with v dash up to u. And that's x plus 1. And then that is called your gradient. What do you guys remember this? Gradient function. I know once you learn it at school, it will get a lot easier, but it'll be good if you can get to like 80 or 90% with me. It's a gradient function, right? It's a function, there it is with x's, that allows you to find the gradient. But it is not the gradient. If you want the gradient of the tangent at x equals 0, what do you think I'm going to say? Right? So it's going to look like this. 0 plus 1 is 1, root 1, which is just 1, plus half. 0 plus 1 is 1, 1 to the power of negative 2, negative half, sorry, times 1 times 1 times 1. Okay, that's, plug it out into my calculator, is 1 plus half, which is 3 over 2. You're done. Okay, what's the problem you're seeing already with multiple choice?
There's a lot of working out.
Good job, right? So we are not going to start with multiple choice in our exam papers. We are not going to start with multiple choice in our exam papers. We will start with our short answers and then come back to our multiple choice. If you run out of time, you've got a 25% chance each way. Best case scenario is that you will have time and you actually do all the working out. Now, this obviously would usually be worth 2 to 3 marks if it was in the short answers. You're only getting 1 mark for the same working out. Okay, so our strategy will be not to probably do this until the very end. All good? Number 8. See how good this is already? We've done a little bit of trig. We've done a little bit of equations. We've done a little bit of calculus. It's just the way it's going to be from now on. Please, you guys. Enough with your textbook questions. Enough with school homework. You got to stop. Which of the following represents the solution to x minus 1 absolute value greater than or equal to 3? What do I do? Come on. What do I do? Quick.
Make it x minus 1 and then make another one x plus 1.
Oh, no. You're on the right idea. X minus 1, and this one can be still x minus 1 equals
3.
and
Positive, negative 3?
that's the idea.
Oh.
So you make one of them positive, x plus. If you had said negative x plus 1, I would have accepted, which means you made the left-hand side negative. But it's easier to make the right-hand side negative. So I don't know why. Yeah, I've done it like this. X minus 1 equals negative 3. You ignore the inequality. Okay, what do we do? X equals? X equals?
4.
4. Boom. X equals? Minus
Negative
3
2.
plus negative 2. Now you know the answer, which is all here. Negative 2 and 4. So what you want to do now is sub in a point. Right? Sub x equals, well, you already know it's equal to, so it can't be D and it can't be C. It has to be equal to. Can't be D and can't be C. Sub in, let's say in the middle. Sub in x equals 0. 0 take away 1 is negative 1. Absolute value of negative 1 is 1. Is 1 bigger than or equal to 3?
No.
So would 0 work?
Nope.
So therefore, they've got to run away, and the answer is A.
A.
Now, obviously, this is a multiple choice. Did I need to go ahead and solve?
No.
All the answers are negative 2s and 4s. So all I had to do was just look down here, and I'm like, oh, all I need to do is just sub in to see where it works. So this one could have been done in like a matter of 10 seconds, and they will do that, where you're actually using multiple choice rather than math. So you're learning multiple choice skills to look at answers instead of math skills. But I wanted to do this because we're doing revision. Okay. The graph of the derivative is drawn below. Not yet. That would be, yeah, not yet. That's part of integration. Maximum turning point occurs at cannot. You cannot do that yet. It's okay. Line L. Okay. Question 10. Question 10 is obviously the last question of the multiple choice. The idea with the HSC is question 10 is usually 95 plus students. I mean, you can guess it, obviously, and you can guess it right even if you're a 10% student, but the idea is if you can answer this question, you're at the 95 plus stage. So let's see what the heck it's talking about. Line L has an x-intercept of -4 and a y-intercept of -2. So, okay, so that means y equals 0 and x equals 0. So line L looks something like this. X-intercept -4, y-intercept -2, something like that.
Mm-hmm.
Line K is perpendicular to line L and passes through the point 4 and 5. X is 4 and 5. There it is. And it's perpendicular. What does perpendicular mean?
It bisects.
No. See, I didn't draw it bisecting. Did I draw it? Look at this. It's a lot longer than this side. So you can't say bisects. I don't like that word for perpendicular.
If you times them together, if you time the gradients together, you
That's
become
better.
-1.
Thank you for fixing that up, because you were about to say if you times them together, you get -1. And then I would have said
Yeah.
times what together? Gradients. It
Yep.
means that they meet at right angles. That's what perpendicular means. In other words, also what you just said, m1 times m2 equals -1. Tangent, if you want to think of it, like this one here is a tangent. This one here is a, what's that word called? What's the equation of that? What's the equation of that line that is perpendicular to a tangent? Any ideas from calculus? Started with n. It's the opposite of abnormal.
What?
Come on. M.
Normal.
Normal. Okay, so it was called normal. So tangents were this way. Normals were perpendicular to your tangents. You find normals by first finding your tangents. Looks like we'll have to revise a bit of calculus, which is fine. Line M passes through the point 1 and 3. 1 and 3. Sorry, somewhere there. And just say it just passes through. It doesn't have to do anything. There it is. Which of the following does not represent any of the lines K, L, and M? All right. Well, a bit annoying, but here we go. Instead of finding each of these equations, because I think that will take too long, right? What do you think I'm going to say to do?
Sub?
Yeah, I think it's easier just to sub in your y-intercept and your x-intercept into, like, let's just say, into the first one and see what happens. If it works, therefore that obviously represents that line. If it doesn't work, you got to go with K and M. You might think that's long, but I think it'll be shorter than trying to find the equation of each line. So here we go to x. X is 0. X is 0. You get y. See, when x is 0, you get y equals 3. And you guys see that? When x is 0, you get y minus 3 equals 0. So therefore, you get y equals to 3. Do we understand that?
Yes.
Yes. Okay, so the first one's not L. B, x plus 2y plus 4. When x is 0, I get 2y plus 4 equals 0. 2y equals -4. Therefore, y equals 2. That's line L. So that's gone. Can't use that. Do we understand that?
Yes.
The idea is, well, I'll keep going. All right. The line M. Line M passes through the point X and Y. X is 1, Y is 3. So X is 1, Y is 3. 1 plus 3 is 4. 4 take away 2 does not become 0. So that's not line M. 1, Y is 3. 2. 2 times 1 is 2. 2 plus 3 is 5. 5 take away 5 is 0. C is line M. That also works, so not allowed. Now we're tossing up between A and D. We know it passes through the point 4 and 5. Just sub it in. X is 4. Y is 5. 4 plus 5 is 9. 9 take away 2 is not 0. So we already know the. Let's make sure. X is 4. X is 4. Y is 5. 2 times 4 is 8. 8 plus 5 is 13. 13 take away 3 is wrong. What happened there? Line K is perpendicular to line L and passes through. X is 4 plus 2 times
Don't we have to
3.
find out which do not represent any of the lines?
Yes, but they both don't. Hold on. 2 times 4. Oh, you're trying to say, wait. That's L, that's M. Are you trying to say M would have worked in here? 2 times 1 is, no, that's still, that wouldn't have worked. Line K is perpendicular to line L and passes through the point 4 and 5. 2 times 4 is 8. 8 plus 5. That won't work. Where have I gone wrong? Line K is perpendicular. Well, I can quickly find line K. Where did I go wrong? Minus 8 plus 5 is minus 3. Okay, they must have done a typo here, which they would have, I'm sure, adjusted in their school exam. I can see the answer should have been 2x take away y take away 3. They've written plus y. That's okay. We'll give it to them. 2 times 4 is 8. 8 take away 5 is 3. 3 take away 3 is 0. So that one would be line K. And the answer is obviously D. Now, obviously, good point that we've realized. Only do the exams that have solutions, so at least you can double check everything and go to the end of the paper and double check your answers. Cool. No, I don't need it. I know that's the answer. Okay. And we go again. Question 11. Rationalize the denominator. What do I multiply top and bottom by?
Root 5 minus 2.
Wrong.
Is this even in the syllabus?
Yep.
Is
What?
it just root 5?
Wrong.
Times by root 5 minus 2 on both sides, top and bottom.
Nope.
Plus 2.
Yes.
Okay.
So, if it was root 5, if it's root 5, you times top and bottom by the root 5. Cool? Yes. If it's a plus or a minus, you do the opposite. Because what must happen, watch this, 3 times root 5 is 3 root 5. 3 times 2 is plus 6. The bottom, that becomes a difference of 2 squares technically. I mean, you can expand it long way, but it'll just become root 5 times root 5, which is 5. 2 times 2 is 4. And your answer is, over 1, which is just this. And you've rationalized, you don't have any surds. If you did what you said, Eden, and some others said minus 2, what would happen is you won't actually end up with no surds in the denominator, which is the aim of rationalizing. Now, it's funny, Eden, you just said, is it in the syllabus, right?
Mm.
This question was asked in the HSC. I'll just do a basic one. There you go. It was question 10, and that was the question. And what students needed to know for themselves to do, because it's question 10. Question 10 usually means, again, 95 plus, or even, if it's towards the end bits of question 10, it's usually 98, 99 plus, is to rationalize the what? What do you reckon? Wrong. The denominator's got no problem, right? Look, it's a H. Yeah, so rationalize the?
Surds?
Yeah, but which bit? Okay, I was hoping you would say numerator. So it's rationalize the numerator.
Yeah.
Which you've never done. But just because you've never done it doesn't mean it's not allowed to do it. You're not allowed to do it. You're absolutely allowed. Because all you're doing here, when you're timesing by the top and bottom, you're timesing by 1. So it's like me saying, hey, can you go multiply by 5 over 5? Well, yeah, of course you can, because you're just timesing by 1. So when you're doing this, you're not really multiplying it by anything. But what you are doing is you're trying to get rid of the surds on the top in this case. And that's just something that these kids needed to know. But is it in the syllabus? No. But does it need to be? No. Can it be in exams? Yes. Should they have been exposed? Yes. How? Doing more exams. It's in exams. It's not in your textbooks. So, yeah, anyways, I think I rest my case with that. Enough talking about that. Let's continue. Differentiate. Differentiate. What don't I like with this expression before I start? There was only two things I wasn't able to differentiate. One was surds, and another one
X in the denominator.
was x in the denominator. So before I start, I have to change this to x squared plus 2x to the power of
-1.
7. And then can you tell me what y dash is, please?
Bracket 3x minus 1 power by a half.
You're looking at the wrong one. This one. Just
Oh,
you're here now.
2
2 what?
2x
Yep.
um
Bring this
plus
down. Bring this down.
-2x. That's it.
You didn't have a look. You brought x squared. You made it 2x. You made 2x -1, which obviously looks different to this guy. But you said it's the same, 2x. Clearly it's not, right?
Oh, yeah.
Anyone help her out? What she's
Power of
missed?
-2.
Power of -2. You forgot to subtract 1 from the power.
Oh, okay.
And then you're done. That's it. Brad, give us the answer for this one then. Again, you can't, so I'll just write it the way you guys need to remember it. No surds, so power of a half. What's y dash?
Y dash. Well, you'd bring down half,
Yep.
and then you'd have 3.
Oh. No. Is the same the answer as this?
No, and then put that on top, it'd be 3 on 2.
No, you've missed a fair bit there.
No, no.
You've got the general understanding, which is good. You said
Wait,
the
no,
most important bits.
sorry. It's 102 and it's 3
Bracket.
to the power of -half. Still?
You got that? No, still.
Oh, man, I don't know then.
All right, listen. Here, you brought the 2 down. True?
Yeah.
And you kept the x. And then you deducted 1 from the power. So, this one here. You bring the half down. You keep this x. That is x. It's just a big x. Whole lot of x's.
Yeah.
So you keep it. You keep the bracket. You take away 1 from the power. And the only extra thing you have to do, which is what you said, differentiate the inside, which is 3.
Ah, okay.
That's how to look.
I see.
The next answer, 3 on 2, which is what you said, and then bracket 3x minus 1 to the power of -half. Or if you want to bring the -half back down to the denominator, your answer looks like this. 3 on 2, 3x minus 1 to the power of half, or square root. Because negatives become positive in the denominator. You know that, right? Okay. More importantly, is this just this step here? You guys got to get used to that step. Lissandro, triple I.
Right.
What are you going to do?
Make a x plus 1 all to the power of negative.
You're not.
No.
This is one of the rules. So try to run through your
Oh.
3 rules, and
Uh,
I remember
quotient rule, sorry.
it is quotient rule because it's divided.
Yeah.
And then the quotient rule, we'll write it on the side. Do you think you know it?
Yeah.
Okay, go.
U dash V.
Yep.
Minus V dash U all over
Over.
V squared.
Done. Okay, here we go. U dash, the first one.
Oh, 2x.
2x. V is this. minus v dash. What's the derivative of the bottom?
1.
1. So that you can just leave it times u x squared all over.
V squared. X squared plus.
Oh no, x plus 1 all squared like that.
Okay.
And then obviously you don't get marks, which is what I said before. We don't get any marks for our denominator. You only get marks for your numerator. So here we go, 2x squared plus 2x minus x squared over, no need to expand this guy. You're left with 2, take away 1 is plus 2x on 1 squared. You guys probably saw they're all worth 2 marks. All right. Any questions? Am I going too fast? Probably a little bit, I reckon. But keeping up. All right. Vinesh, are you keeping up with all the work as well? Because we're doing a bit of revision.
Yeah.
Cool. All right. Find the equation of the normal to this curve at x equals 1. All right. Firstly, before we start, what was the formula? Oh, all right. These equilibrium questions, no longer part of the syllabus. So gone as well. You haven't seen it, so you know it's not in. All right, wait, this one. Find the equation of the normal. What was the big formula that I said, you guys, I want you to memorize it. Equation of a line. Of any line. What was the formula?
Y minus y1 equals m bracket x minus y sorry,
Okay.
x minus x2 1.
X1 still. Yep. Good. And x1, y1 is a point. I've got x equals 1. What do I need to find this? I've already got one of my points, which is x is 1. What do I also need to find? So I've got x equals 1, right? So for x1, it's done. It's 1. But I don't have y1. How do I find the y coordinate?
Sub in x.
Yes. Don't overthink it. X is 1. If I sub in x is 1 here and x is 1 here, what letter would you solve for?
Y.
Obviously, yeah. Good. So that's it. 2, take away 11 is -9. -9 plus 1. Bingo. Y is -8. You got yourself 1 mark out of 3. Okay. Equation of normal. How do we find the gradient now? So I've got my point. And how do I find my gradient? Firstly, how do we find gradients of curves?
I don't remember.
Okay. Anyone help us out? Gradients of curves. You do. You just don't know. It's what I was telling Eden just before. You just got to study so you can learn the. You got to learn the words pretty much. That's where you guys are in. So as you do more and more, you're going to get used to the words. Eden, gradient of curves. Any ideas? What topic? No?
Function?
That's fine. Leave it. Rad, gradients of curve. Any ideas?
Well, I know first thing I do is differentiate the thing.
That is right. The gradient of the curve is to differentiate.
Yeah.
Please
And then
say-
what is it? I'd sub in
That's where we were getting stuck at. Gradients of curves is just to differentiate. In fact, gradient of anything, even if it's a line, you can just differentiate. So calculus it's the most powerful thing. Y dash equals 14 x to the power of 6 minus 11. Keep going, Rad. You have differentiated, so what?
Well, I differentiated.
Normal. But to find the gradient of the normal, I have to find the gradient of my tangent first. How do I do that?
The gradient of the tangent.
Yeah. This has got x to the 6. That's really weird. That's not a gradient. It allows me to find the gradient. What do I have to do?
I'm not sure. Is it? Oh, is it the thing where it has to equal -1?
Oh, no, that's for your gradient of your normal.
That's for the normal. I don't know.
All right, anyone help him out? Maybe
Isn't
Lissandra?
it the gradient function?
This is your gradient function. Now you finished it off. Yep, you've already got y dash. How do we find my tangent though? The gradient of the tangent.
Y minus y1. That
No,
equation.
that's the equation of your line. So let's get something clear then. All right. You're gonna have a curve. Let's really understand this. And query now before it's too late. So ask me questions now. You've got a function, y equals x squared, right? Now, what you've just learned is that in calculus, you are allowed to differentiate. And if you differentiate, what it finds you a gradient function. And a function, all a function means is a relationship. It finds you a gradient relationship or something, right? So this allows you to find the gradient. Allows you to find the gradient. So differentiation finds you the gradient function. That gradient function allows you to find the gradient. So when I go and say, oh, here's y equals x squared, and here's y dash is simply 2x. Is that the gradient of my tangents? No, because that allows me to find the gradient of my tangent anywhere. I don't want it anywhere. I want it specifically at x equals -1, x equals 3, x equals 15. What's my gradient of my tangent at -1? What do I do to find the gradient of my tangent? First you differentiate, there it is. Once you find it, that's called your gradient function. Allows me to find my gradient. I got to sub it in specifically there. So at -1, it's -2. At 3, it's 6. At 15, it's 30. Do we really get that now? Tell me if it's a no.
Kind of.
No.
Okay, what bit confuses you? Yeah, just tell me, I need to know which bit. So like, let's say, Lisa, which bit do you go, now hold on, what just happened there?
I don't know.
Okay.
I don't know.
All right. Eden?
I'm not sure how to find the gradient function.
So to find the gradient function, you have to differentiate. And how do we differentiate?
You bring power down.
Power down
minus
and
1.
equal 1. Yeah, that's it. So there it is. That's called gradient function.
Okay.
These ones here are called your what? Just G.
Gradients.
Gradients. So the only way you can find your gradients is by first finding your gradient function and then specifically subbing it in at the point you want.
I don't understand. Where's that in the question above?
I'm just making sure this is not in the question above. I'm just making sure we understand how to find gradients and everything like that.
So find gradient, you just differentiate and then you just sub in what he says.
That's it. See, that's what I want you to say. Yeah,
Yeah, that's it.
but you didn't. You weren't saying that when we were up here, right?
Yeah,
And
no.
I-
Where's those numbers? Where's the tangent?
well, hold on,
Wait,
hold on.
you know what I
hold on,
mean?
hold on. Oh, no. Hold on. Okay. So once you find your gradient of your tangent, yes,
Yeah.
then and only then can you find your gradient of your
Normal.
Normal.
normal. Only. You can't find your normals until you find your gradients of your tangents. You can't find your gradients of your tangents until you find your gradient function. You can't find your gradient function until you have differentiated.
Ah, okay.
I think we just had that moment. That's it. That's the moment we're looking for. All right. Find your gradient of your normal. It's negative reciprocal of this, which is a half. Your gradient of your normal here at x equals 3 is negative 1 over 6. Your gradient of your normal here at x is 15. It's negative 1 on. It's a bit better. Lisa, Eden, Rad, all of us. What do we reckon? Still? Or good? You think you can explain that and you really get that?
Yeah, I think I'm all right.
You think you really get that now? So if I was to come up to you in the middle of the street and I go, hey, Lisa, quickly tell me, how do I find the gradient of a normal? You're going to say?
I'm just gonna run away.
So you're going to say, all right, we'll differentiate it, right? Then I find my gradient function. Bang, got my 2x, no problem. Then that allows me to find it anywhere. You want here, anywhere. But the question's obviously going to tell you to be specific. You'll say at, like in this question said, at x is 1. You know, so therefore you sub it in at those values, whatever it would be. There, you found your gradient of your tangent there. You find your gradient of your tangent there. You find your gradient of your tangent there. You can't find your gradient of your normal straight away. Once you find your tangent, you know that tangents and normals are perpendicular to each other. So that means that once you find your gradient of your tangent, your black lines, you can work out your red lines by doing negative reciprocal. And that's it. That is this pretty much this whole topic summed up in a simple case like this. So, Eden, good?
Yes. Yes.
Fully good? For like at least like let's say 90% good?
90% good. I just need like some more exposure to it.
Yeah, that's the exposure bit will come. It's just more about you knowing that. So if your teacher started, you're just like, I already get what you're saying straight away.
Yeah.
You know what I mean? I can't. It can't be like, oh, okay, yeah, because then you'll learn it their way, and I don't want that. I want it done my way. Because it gets really hard with calculus if you're going to learn it a different way. All right, so let's go back. The question said, find the equation of the normal. The first thing I think about is equation. I understand to do an equation, I need this formula, which I think we all agree with. Do we all agree with that? That's an equation of a line. A normal is just a line. It's a fancy way of saying a line, but equation of a line. I know I need x1 and y1, and I need a gradient of my normal. Right? I need my gradient of my normal. x1, y1, we found out how to find it. Have any questions about finding the y value of this? Do we have any questions about that? Okay, then the next bit we learned is to try to find the gradient of my normal. I now know to find the gradient of my normal, I have to differentiate, which is 14x to the power of 6, take away 11. That is not my gradient. That is my gradient function. So that means that allows me to find the gradient anywhere. Do we get that? Why does that allow you to find the gradient anywhere? Because it's still got x. So it's any x value. So if you want it now at x equals to 1, what's your gradient of your tangent?
3.
First, 3. What's your gradient of your normal now?
1 on 3.
Negative 1, 3.
So
Negative.
1 on 3. Yeah.
You just said negative 1 on 3. You already got 1 and negative 8. It's just a matter of subbing it in, and you got 3 marks. So here's the answer. Y minus y1, so y minus minus 8 equals negative 1 on 3, bracket x minus 1.
Sam, where did that minus 8 come from?
Where that minus, okay. We need a y value. Do you agree with that?
Yeah.
First, okay. If I've got an x value of 1, what is the technique that you know if you know x is 1 and you've got an equation to find y? How would you find y?
I just put in 0.
Oh, okay. That's only specifically for y-intercepts. So what you just said is sub in x equals 0 to find y-intercept, right?
Yeah.
If I already know x is 1 and not 0, I can do the exact same thing.
Sorry,
You
yeah.
just sub in 1.
Yeah, okay,
So-
sorry, yeah.
If
No.
I wanted at negative 1, you'll sub in negative 1. You'll find the y value at negative 1. If I wanted it at, at a, you'll sub in a. You know what I mean?
Yeah, I see.
Which would literally be this whole thing just with a's. All right, and then there it is. And if you want to fix this up, it becomes y plus 8. I like to get straight into it because I know. Whoa. I know what is happening. Stop it. Oh, it's writing by itself. All right. I know that theory is only step 1. So by the time you cover it at school, it's only step 1. You need to get to around step 4, step 5. But by the time you guys only do it at school, it's usually step 2. So you learn it once at school, and then you try to revise it before an exam, and that's it. You will fail every single time you try to do it that way. You have to try to at least get to step 4 or 5, which is 1, learn it with Sam, let's say first. 2, revise it with Sam. 3, learn it at school. 4, revise it at school. 5, revise before an exam. Then you'll go into your exam and you will not get less than 90%. You guys got to understand that. It just will never happen. Never had one student that's done that and has got less than 90%. 3y plus 24 equals negative x plus 1. Bring the x's over if you wanted to, or whatever you want to do at this stage. Doesn't really matter. You would have got 4 marks in the HSC for the first line, just so we're aware of it. 4 marks for the first one because the question just says find the equation. It doesn't say specifically write it in general form or gradient in-step form. If it's a find the equation, the y minus y1 line step. Okay, this looks familiar. Evaluate. What does evaluate mean, Eden? We spoke about that at the beginning.
Give a number.
Yes, so this has to give you a number. Whether you like it or not, it's got to give you a number. G of negative 3, what do we do?
Substitute negative 3 in x.
9. 9 plus 1 is 10. You got yourself 1 mark. For what values of x is g of x equal to 2? How do we do that one? What do we just write?
2 equals x squared plus 1.
I agree. Does anyone disagree or not understand how that worked? No, we understand. G of x is 2. Okay. Eden, you might as well continue. Next line.
You move the 1 over, and then you square root it.
X equals?
Plus minus, 1.
Thank you for saying plus minus. Good job. X equals plus minus 1. You got yourself another mark. That's question 11. Good. Very, very good. All right, let's go. Question 12. Rad, you ready?
Yeah, what question?
Here we go. Question 12. Given that the point -3, comma k lies on the line, blah, 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 evaluate k. What do you do?
Sub in -3 for x and then k for y,
And
and then evaluate.
easy stuff, man. Come on, what's your answer? Just by looking at it, what's your answer?
7, 10.
-3 minus 7 is -10. Bring it over. Positive, and then divide by 5. What do you get?
2.
Done.
Yep.
Easy stuff. Cubics with a number out of the syllabus. Don't look at that. C. Given g of x equals square root of 36, take away x squared. Anyone remember what this is? What function this is?
Semicircle.
Since we're here, let's just draw it. It's a semicircle.
Isn't it 6?
That again? Ah,
Isn't it 6?
thank
Yeah.
you, thank you. Your domain is -6 to 6. Your range is from 0 to 6. So we've already answered this one. Show that it's an even function. Okay. I showed it in a very specific way to prove things are even functions. What's step 1? Step 1, come on, help me out. G of what? I think Lysandra, G of what?
G of x should be equal to g of -x.
Yes, so what's the first step? You sub in G of?
Any number, 1.
No, wrong. You're proving exactly what you just said. G of x equals G of -x. So
Yeah.
step 1, even or odd or neither, is to always sub in -x.
Okay.
Step 1. Right? Any question, it doesn't matter if it's even, odd, or neither. That becomes square root of 36 minus -x squared. What happens? What's this bit squared?
It just becomes -x.
So
It's
36. Well, no, -x. Yeah, that becomes
Yeah.
negative.
Like the whole thing becomes -x.
Yep, perfect. Which is,
G of x.
so if the idea was you always sub in -x, these were the steps. If it gives you the original, sorry, Eden?
Yep, I remember that now.
Okay, yeah. Sub in -x. If it gives us the original, happy days again, no problems, it's even. If it doesn't, what do we do?
It's called an odd.
You
Oh.
take out the negative.
Yeah, that's the one. Be careful. If it doesn't force out a negative, that means it's got to look something like this. Like let's just say -√36 minus x squared. And if it gives you negative of the original, then you would say it's odd. And if it doesn't,
It's neither.
yeah, so Sandra, you just said if it's not even, it's odd. You gotta be careful because there's still an answer of neither. So if it doesn't force out a negative, these should be your steps. Cool. Every exam paper will have this. So as we keep doing it each week, you guys will just start to learn to memorize. And again, just so you guys know, my first paper, I would have got around 20 to 30% overall. So it was horrible. It's as bad as you guys are finding it now. So don't worry, it's okay. We'll get better. Cartesian is in it, except perpendicular distance is not. So let's do the first bit. Okay. In the diagram below, the lines 4y equals 7x plus 21, there it is, and 4y equals 31 minus 3x intersect at the point B. Point A has coordinates -3 and 0. Point C has coordinates 5 and 4. Show that the line AC has equation this. Okay, equation of a line. What's the equation of a line formula?
y minus y1 equals mx minus x1.
Gradients. There's a million ways of finding gradients. Rise over run, y equals mx plus b, differentiation, tan theta, and if you've got 2 points, you can find the gradient using y2 minus y1 on x2 minus x1. So y2, x2, y1, x1. So there's a lot of ways of finding gradients. You guys got to get comfortable with that. The most important one you want to remember is differentiation. 4 take away 0, because that's what's going to take you on to year 12. Over 5 take away 3, which is plus 3. That's a half.
M equals a half.
Yep, and then pretty much y minus y1, let's just pick 0, it's easier, equals half x plus x1, or x minus x1, sorry, plus, times it by 2, you're done. Double A. Any questions there? Okay, show that B has coordinates 1 and 7. All right, how do we find B? How do we find B? I pretty much highlighted or tried to highlight the answer so you guys can focus on that.
Oh, simultaneous.
Correct. You've got 2 lines and they intersect at B. The best way to find it is to obviously do simultaneous equations. The way I also think about it is, I mean, this is x, this is y. I need to find x and y. That means I need to have 2 equations. There's your 2 equations. All right. Can you see how they're not going to be in line if I write 31 take away 3x? Be careful. Rule 1 that you've learned is always keep things in line. So I rearranged negative 3x and 31 so that they're in line. All right, what do I do to solve these 2 simultaneously? Both for y.
You take away,
Yep.
like, downward.
So that becomes 0. 7 take away 3 is plus, so 7 plus 3 is 10. 21 take away 31 is negative 10. I think we can clearly see that the first answer is x equals to 1, which is what we need. And then sub in 1, sub x is 1 into 1, and we can cheat a bit, can't we? Y equals 7. We already know it's 7. But you can get 7 plus 28. 21 is 28. 28 divided by 4 is 7. Cool. Easy, easy. Find the exact length of the interval AC. Oh no, you can't do that because you need that one, and then you probably can't do those ones as well. Okay, all good. I'll have to find you some ones that are more relevant for your new syllabus. All good. Okay. E. Last one for this question. For what values of k does this have equal roots? Now, I don't think I've gone through equal roots and discriminants yet, so I know that I can talk about it right now. So let's have a quick look into roots together. So I did say the discriminant. Now, has anyone not heard of the discriminant yet? Okay, so we've all heard of the discriminant. Great. The discriminant is equal to b squared minus 4ac. And the idea of the discriminant is obviously it comes from our
Quadratic
formula. So the idea of it is it's just trying to say if the inside of your surd, if the inside of your surd is less than 0, then the inside of your surd will give you a negative number. You can't square root of negative number. And if you can't square root of a negative number, so if your discriminant is less than 0, you'll have no real roots or no roots. Right? Can you guys see it that way? Do you get that? Eden, for example, Lisa, Tiana, do you guys get what I'm saying there? If that's less than 0, how it has no roots? Because
Yeah,
you won't be
that
able to
makes
solve for x.
Yeah. I always had trouble with this.
Yeah, I know, it's a bit confusing because it's a bit more, I guess, again, it's a bit more studying than it is mathematics. So you've got to understand what's happening. The discriminant, and if it equals to 0, again, how many solutions will you have if it equals to 0? Well, quickly do it. Like, you get x equals minus b plus minus square root of 0 over 2a. What happens plus minus root 0? All gone. How many solutions will you get? 1, right? It's just x equals negative. Do you get that? Again, I just proved it. Yes?
Yes.
And last one, if the discriminant is greater than 0, so if that's any number that's greater than 0, you're going to get one that's plus, then you get another one that's minus. So how many solutions will you get? 2 roots, 2 solutions, 2 x-intercepts. They're all called the same thing. It's important that you guys learn the words. The solutions, x-intercepts, answers, whatever. Okay. This one root is also equal roots. Why is one root the same as something having equal roots? It's because technically a quadratic should have how many roots?
2.
A quadratic should have 2 roots. But with this equals 0, the roots are the same. The 2 roots are the same. So we usually just say, oh, there's 1 root. And that means those 2 roots are equal. They're equal roots. Equal roots. 1 root, those 2 roots are just equal. They're equal to the 1 root. Does that make sense?
Yes.
So root is also the same as equal roots. Okay, and obviously all you've got to do is just, once you know this question says, for what values of k does this have equal roots? Now you know that means discriminant equals 0. What is the discriminant equal to? B squared minus 4ac. Okay, what's b? What is b equal to in this expression?
4.
I think I heard 4, which is close. B.
So 4 plus
Negative 4.
Negative 4.
Yeah.
Just I want to make sure that we remember that. Even though it doesn't matter with your squared, Lisa, be careful. You know it should be negative 4. Minus 4 times a. What's a?
K.
C. What is C?
1.
Wrong.
Oh,
I
K
knew-
plus.
I knew you were going to say 1. And that's bad. If
Mm.
I know something, it's bad. That means you're still looking at it the way you're not meant to look at it. So A, B, C.
Okay.
If it doesn't have an X, it is a constant. It has an X, it's not the constant. Rad, you get that? Vinesh, you get that? Lissandro, all good?
Yeah.
C, K plus 1. Negative 4 squared, and then, it's just a matter of solving, isn't it? Or K squared plus K equals 0. Expand 16 minus 4K squared minus 4K. All right, and then what do I do when I see something like this? Or negative
Factorize.
4. Say it again. Factorize. Fair enough, if you say so. So I would divide by -4 first, just to make this positive k squared plus k minus 4. And I can actually tell you can't factorize. What's your next option if you can't factorize that?
Quadratic equation.
Yeah, that's probably what I would have jumped into straight away. A, B, and C. But anyways, k equals minus b plus minus square root b squared minus 4 times a times c all over 2a equals 1 plus 16 is 17. So your answer is -1 plus minus root 17 over 2. So as long as, it's important you guys get this, as long as k is -1 plus minus root 17 over 2, this solution of this equation will have only one root. Do you guys get that? Because you know what I've heard all the time, right? I've heard, but Sam, you just said I'm only meant to get one root. If I'm only meant to get one root, how come I got 2 roots? Where are they wrong with that? Where is the understanding wrong? What is the understanding? What is wrong in that? But you said they're equal. How come plus and minus? I didn't get it. Where are they going wrong?
Is it because
You might know it. Say it.
I was gonna say like it's technically the same except it's positive and negative, but like
No, not allowed. No, that would be different. That would be this one again. 2 roots. You can't say that.
Because they both
Well, you-
equal the same number?
Say it again. Oh.
I don't know.
Okay, it's a trick question. What about that?
Lovely.
The thing is, look, even if you're trying to solve this first one here, you're going to get answers, aren't you? You're going to solve for k. The idea is, what letter are you solving for here? No roots, 1 root, 2 roots. What letter is this for?
Delta.
No. What letter? What letter?
Okay, sorry.
No, it's actually not. So when you're doing roots, what letter are you usually solving for?
X.
X. So these are actually for x's. So roots are for x's. It's just saying, well, for what values of k would the x's have equal roots? That's what this means.
Oh my god.
Oh my God. Exactly.
I'm a bit confused.
Yeah,
So,
okay.
yeah. Just let me say it again. Let me say it again. But wait, it's got to be clear. So, I mean, look, you guys have done it, and you've never questioned. I'm just questioning it because you usually, I mean, at this stage of your math, you start to question it because you're like, wait, I don't get it. How come this was meant to be 1 root, but you're saying now you've got plus and minus, and then the idea is actually you're looking at 2 different things. This letter is k. When what you found here is k. When you found this k, you're finding the condition for k such that x will have 1 root or equal roots. So k can be any answer. K can be 1 answer, k can be 2, k can be 5, k can be 20 answers. It doesn't matter. K can be anything. I mean, that's what we're solving for. Such that when you solve for this with the k's, eventually, it will only have 1 root. Now, what letter would you solve for when I'm saying when you solve for it eventually? Yeah, that means X. So what's confusing to most students is the fact that they think X's and K's are the same thing, but they're actually not. They're meant to be two different, completely different things. K is just a number in front of X squared. You know, K is just this letter here that's part of your constant. So what you're finding is as long as K is this, when I solve for that function, whatever it would be with the K's in there, that function for your X's will only have one root. And that K value needs to be -1 plus root 17 over 2. As long as K is that, when I solve for X, X will have one root. Is that clear?
So you don't actually need to like solve anything else, as you the answer is just like
no.
K.
I mean, that's the answer, right? Yeah, K equals -1 plus minus root 17 over 2. That is the answer. For what values of K does this have equal roots? The problem, you're done, like just so you guys know, like, that's done. If you're looking for the answer, that's it. The problem is a lot of students come up to me afterwards, once you're at your stage and maybe towards the end of this term, beginning of next term, you'll start questioning because you're like, wait, but how come? Because technically one root, you're meant to say, I'm only getting one solution. How come I'm getting two solutions? Or, oh, Sam, you said no roots, no solutions. So how come I'm getting two solutions? I'm confused. Well, these are for X's, not for K's. You're just finding the condition for K such that X will have no roots, or such that X will have one root, or such that X will have two roots. So don't let that confuse you. Don't go, oh, but I got two solutions. How come I meant to only get one solution, so I cross out one. No, it's fine. It's right. Like K is meant to have two different solutions. Okay. Are we still confused, or do we get the? I just want to answer a question that I know will come up eventually.
No, I think I understand.
It's just that K is a condition for X to have equal roots, and that's all. You found the condition.
Okay.
Again, something we were talking about at the beginning. You started off with calculate. It's important that you guys see it like this. You see this word here? It says values. When I see the S there, it's there on purpose. It actually means you're meant to get two answers for K, two or more, obviously. So it's plural for a reason. So for any reason that they wrote for what value, it actually means the answer is there's only one answer. Cool? That's just an exam trick again. It's got an S there, it means two or more. It doesn't have the S there, it means there's only one answer.
They would never try to trick us, right?
No, it doesn't work like that. No.
Okay.
All right, cool. Let's keep going. Question 3. Hey, there's the question you guys love. Trig. Given theta must be between 0 and 180. What does that mean? Where is it? Given theta must be between 0 and 180. Where is S and A? So it's somewhere here and here. Tan theta is -5/3. So tan is negative here, right, and here. But we'll continue. Tan theta is -5/3. Finding exact value of cos theta. Anyone remember if you got one trig, how to find the other trig?
You draw the triangle.
Oh yes, love it, Sandra. Keep it up like that. Theta, opposite over adjacent, and then square root of 25 plus 9. 25 plus 9, 25 plus 9, 34. Thank you. And then obviously you can work out cos theta. That's easy now. Adjacent over hypotenuse. Done. Full marks. But, sorry, not full marks. Close. But the only thing you've got to check is cos actually positive or negative?
Negative.
Correct. How do you know that?
Because if tan's negative, then it wouldn't be an A. And since it's under 180, then it has to be an S.
Actually here, and if it's in S, that means S and C are both going to be negative. Good job. So it's not there, it's here and here. So it's negative here and here. Good job. Negative 3 on root 34. Perfect. Eden.
Yes.
B. Can I do it?
Okay.
Can I do it?
Yes. Wait.
It's geometry.
Geometry. Okay.
You can see it. Like, look, it's got a picture, has these words, 90 degrees, and similarity, congruency, all of that's gone.
Okay.
Stationary points, no, not that's year 12. Find all possible values for theta, for this triangle shown below. Okay. All right. It's either sine rule or cosine rule. So sine or cosine. Go. Any ideas?
Oh, wait, no.
Yeah, cosine. Problem with cosine rule is what? What's the formula for cosine rule? Do you know it?
It needs to have another side.
It does need to have another side. Good job. So cosine rule is absolutely wrong. It is sine rule. I will tell you how I start with all these questions. If you want to know my strategy for doing if it's either sine or cosine, I don't actually do sine or cosine. I always start with sine. If sine fails, then I know it's cosine. Cool. So my strategy for me is always do sine. If it fails, it's cosine. So sine, I know that, yep, perfect. I've got this and this opposite. I've got this. I don't have that. It's really strange, but I want to find this. But I don't have that. But I want to find this. What the?
Do you do sine rule to
What do I
find
do?
the other angle?
Yeah, that's it, right? It doesn't matter
Angle
if
sum
you.
of a triangle?
That's it. You find it anyways. Sine rule, and then you'll obviously do angle sum of a triangle. Perfect. So let's do it. What is this formula? It's going to be sine x on 9 equals sine 35 on 6 times it by 9. By the way, again, this is how your exam would look like. So every question we're doing is literally every single question you'll get in your exams. Not one question will be missing. Like not one question will be different. You'll get a sine rule or a cosine rule. You'll get a tangent normal question. You'll get, I don't know, solving tan. If it's cos or whatever. All right, x equals 59 degrees if I round it to the nearest degree. And therefore theta equals 180 minus 35 minus 59, which is 86. Any questions? What if I told you you only got 1 mark?
But why?
Yes, exactly.
It says all possible values.
That's it. See? So I want you guys to look at now. Come on, we're at that stage now. You got to start questioning things. You got to start thinking of exam-style questions or looking at exam-style questions. Possible values. That means you're meant to get 2 answers or more. So obviously you've done something wrong. Where would you get 2 answers from, you think, Lissandra?
Ooh,
At what stage would I have got 2 answers? First, second, third, fourth.
Mm,
Where do you think usually with trig you're meant to get two answers?
I'm not sure.
Anyone? Which part of trig do I usually get two answers? First line, second line, third line, fourth line. All right, all good.
Second.
All third, actually. All stations to central. You know, whenever you solve inverse sine of this to get 59, that's only one answer, which we've accepted usually, because it's usually only been for a triangle. And when you do like 180 plus 59 or something, it's too large. But with sine, sometimes you can get an angle that's 180 minus 59, which is 121. And if you did angle sum of 35 with 121, and then subtract that from 180, actually you get another answer. Theta can be both 86 and 24, and all of this will still work. You'll still get 35 there, 6 there, and 9 there. Crazy, right? But that's how that works. The trick to it is obviously knowing the fact that the word said values for you to do it. Otherwise, it will just say find theta. Find theta. Find theta. That would have just been 86. Okay. All right. Good. Sorry. B. If I've got this question, we know the way we prove, we start with sides. So left-hand side equals to this thing. What would you do? What do you think I would say?
Would
Well-
we convert the 2 cosec to
No, I'm
2?
doing left-hand side. Right now, I will do what you just said. That's fine. Here you go. Boom. 2 over sine. I like it, but still, just work on the left-hand side. What would I have done here on the left-hand side now?
Multiply?
What do you mean?
Like, make the denominators the same?
Good. So that's exactly what I would have said. I would have said, what? 2 fractions? Never. Cross multiply, common denominator. So your common denominator, if you can see this, that's just a difference of 2 squares. So again, 1 minus cos. Cross multiply, so that becomes sine theta times 1, which is just sine theta, plus sine theta times cos theta is just sine theta times cos theta, plus sine theta times 1 is sine theta. Sine theta times negative cos is negative sine theta cos theta. Almost there. This and this cancels out. Sine plus sine equals 2 sine. Anyone remember what 1 minus cos squared becomes?
Oh, sine squared.
Ooh. If you didn't, use Eden's trick here. She said it's 2 on sine theta. If you know you need 2 on sine, you know now you had sine theta on the top. You know you need sine squared, so you can cross it out. So that you're left with 2 on sine theta. So you can kind of cheat, I guess. You didn't know 1 minus cos squared was sine squared. You should have just written sine squared. Equals right hand side. Beautiful. 2 marks. All right. I guess harder indices question out of exponentials and probably indices. What do you see? What do you see?
Could you split the 6?
Yes. To what? Split the 6 to what?
Sorry?
Say it again.
Like 2 powered by x times 3 powered by x.
Oh, I like it. I like it. And what about the top?
2x times 2x, the 2 power x minus 2 power x. Yeah.
I'll leave it, actually. Why? You said that's what you said. Okay. And then what would you do?
Factorize.
So you got 2 to the x on the top, open bracket. You're left with 2 to the x minus 1. Do you agree with that?
Yes.
Over. What are you left with at the bottom when you factor? Sorry, what do you have at the bottom when you factorize?
2x. Oh wait.
No.
3x. 3.
Open. And then
2x minus 1.
you know that's got to happen, right?
Yes.
You know these guys got to cancel out. If you've done enough questions by now, you know things are meant to work nicely. 2 to the x over 3 to the x, and that's your answer. Finished. Equals 2 to the x on 3 to the x. If you wanted to, I mean, you're not going to lose a mark for it or gain a mark for it, but you could have written it as 2 over 3 to the x. So that's 4 marks. Finished. Well done. Locus, no locus, out, gone. Yeah, out. No, not for you guys. Maximum area. Anyway, this looks like geometry to you guys, so no, this won't be in your gone. Cool. We just did a whole yearly paper. You know, missed a few
Yeah,
questions, obviously, but that's good. And a bit of we're going to keep doing that each week. The link I've sent you to your Skype. Okay, I've sent you, and should all be there. Let's go do a 2013 one. Maybe just some multiple choice. Okay. If 2x squared minus 12x plus 11 is expressed in this form, what is the value of c? Okay. What is this saying to do?
Factorize.
What specifically like this? Come on, help her out. Come on. You said factorize. I said a bit more specific. Think of the top
Would
here.
you take out 2 from 2x squared minus 12x and leave 11 by itself?
Okay. Yes.
But none of the answers are.
No, no. It's not like that exactly. You're still missing the technique. Like, I accepted that, but there's still a technique you're missing. What's the
Difference of this?
No.
Nope.
Keep saying stuff. Don't worry. Keep going.
Mm,
What have you learned in this topic? You said factorize. I said no, but be more specific. So it is factorizing. It's just more specific factorizing. From here.
Oh, perfect. No, the
And what's that called?
Perfect
Perfect.
square.
Yeah, but what's it called? Like to get it to that from here.
perfect
See-
negative square.
I'll give you a clue.
Complete the square.
Yeah, complete the square. Question 1. It's already got us. How good's that? Complete the square. So that one's a complete the square question. So what you've got to do is, I'll accept what Rad said, factorize the 2 out. That's not a problem. I usually bring my constants to the other side. We know that. We half this term, half the 6, square it. And what we've got to add here is 3 squared times by 2. So you don't just do 3 squared. So usually we've learned halve it and square it. But if you've got a 2 in front, it's halve it and square it and multiply by this number. So 3 squared is 9. 9 times 2 is 18. And I think we already know the answer. Negative 11 plus 18 is positive 7. You bring it over. The answer is B. That was a complete the square question. Anyone still not comfortable with completing the square?
Kinda.
Which bit? Because
Um,
I'm sure you understand some lines. It's probably more
Yeah.
this line here.
yeah, kinda.
Because me, I wouldn't have also factorized 2. I would have personally divided by 2.
Like when it comes to dividing, I'm not sure what I half and what I square.
When it comes to dividing, I'm not sure
Like
what I...
say it was like, yeah, say it was like 2x squared, then it was like this equation, and then we had to divide everything by 2. I get a bit confused on how to complete the square when everything's divided by the constant.
Here.
Yes.
So then you divide everything by 2.
Yeah.
You get x squared minus 5x on 2 equals negative 11 on 2. Because you bring your constants to the other side. You know that, right?
Yeah.
Okay. Open bracket, squared. X minus half of this. What's half of 5 on 2? Do it on your calculator if you have to. Go 5 on 2 divided by 2.
5 on 4.
5 on 4. Then what you do, you add that number, if there's no number in front, which I haven't done in this case, you get that number and you square it and you add it to this side. So get the number on your calculator, just press squared. And that's the number you add onto this side. You get that?
Okay.
In this case, I did 3 squared, which is 9, but because there's a 2 in front, you've got to still multiply by 2. And that becomes 18. All right.
Okay. Yes.
Try one more, because this looks like it's exactly the one that we just did. For what values of k does this equation have equal roots? What do we do? Equal roots.
0. It has to equal
What equals 0?
x equals 0.
Wrong.
Wait.
Yes. No, not yet. Wrong. X doesn't equal 0. X has 1 root. What equals 0?
Y.
Nope. There's no y's. Do you see y's?
The derivative.
Discriminant.
Discriminant.
Oh,
Okay.
I discriminant.
The discriminant equals to 0 has equal roots. Don't worry, already it'll get better. Believe me, next week you'll be from 20%, you guys will move to 35%. From 35, you'll get to 60. 60 will become 65. And then it gets slower there, and then we'll get there. So don't worry. Discriminant equals 0. B squared minus 4AC equals 0. B, 9 minus 4 times A times C. 9 equals 4K. K equals 9 on 4. All right. And then what is the derivative of this last one? I know I said that. I just saw this and I'm like, I have to. Brad, give it to me. Come on. Y dash equals.
Y dash equals 3
Bracket.
x cubed plus 4
Close bracket.
2
Times.
times 2x to the power of 2, and that's it.
Oh,
Oh, sorry,
you said-
3x to the power of 2.
Yes, done. And then the
Yeah.
answer is 9x squared.
Yeah, that's it.
Finished. Done. Guys, get out of here. You smashed it. So we're going to do better. Believe me. I'm just worried about your schoolwork. You know, you guys are, I don't want to go back to school